OCR Maths and Stats differentiation techniques used for C3 and C4. Differentiating any function that's raised to a power. Any function that's raised to a power. So looking at the formula, n, the power, comes to the front, and then we take the original function f of x here, and that's raised to the power of n minus 1, so you just subtract 1 from the original power. But we're not quite done. We need to multiply by the derivative of the original function here. So n, the power, comes to the front, and then you multiply by the original function to the power of n minus 1, so you subtract 1 from the original power, and then you multiply by the derivative of f of x. And this formula works for any function raised to a power. Differentiating 3x minus 2 to the power of 5. So 3x minus 2 is the function on the inside, like this. There's the f of x, that's the 3x minus 2, and that's to the power of 5, and n here represents that power of 5. So differentiating, we start off with n, so we start with 5 times the derivative of the function inside the brackets. So if we differentiate 3x minus 2, we get 3. So that's these two parts completed in the formula. And then we multiply by the original function inside the brackets, which is 3x minus 2, to the power of n minus 1. So we subtract 1 from this power, so to the power of 4, and then just simplifying, 15 times 3x minus 2 to the power of 4. The great thing with using this formula is that f of x can be any function of x. We're not restricted to linear functions of x, for example. This could be anything. Differentiating 1 minus 4x squared to the power of minus 3. So f of x, the inside function here, function inside the brackets, is 1 minus 4x squared, and the n in the formula here is the power of minus 3. So using the formula, we start with n, so that's the power, that comes to the front, minus 3. You multiply by the derivative of the function inside the brackets. So differentiating 1 minus 4x squared will give minus 8x times the original function in brackets. So the original function inside the brackets here is 1 minus 4x squared, that's this part here, to the power of n minus 1. So if we reduce this power by 1, so minus 3 minus 1 will give us minus 4, and then we can simplify to give us 24x times 1 minus 4x squared to the power of minus 4. In this example, f of x, the function inside the brackets, is 1 plus x cubed, and the power n is 2. So we can apply the formula, but once we've differentiated, we must multiply by 5. So the power comes to the front. That's the n times the derivative of the function inside the brackets. So differentiating, the 1 plus x cubed gives 3x squared times the original function inside the brackets, 1 plus x cubed, to the power of n minus 1, so subtracting 1 from the original power, and then we need to multiply by 5, like this. And then we can simplify this result to give us so once you have the derivative, then you can go on to work out things like the equation of a tangent, a normal, coordinates for stationary points, and so on. Differentiating sine cubed 2x, which is the same as sine 2x in brackets cubed. So we can still use this formula. You can see the function inside the brackets is sine 2x, and n, the power, is 3. Using this diagram here for differentiation, if we differentiate sine going in a clockwise direction, we get cos. Differentiate sine to get cos. So the function inside the brackets this time will be sine 2x, and the power, n, is 3. So differentiating, starting with n, the power, which is 3, times the derivative of the function inside the brackets, so times the derivative of sine 2x. So differentiating sine gives cos. So differentiating sine 2x will give us 2 cos 2x times the original function, which is sine 2x, to the power of n minus 1. So the power here is 3, so if I subtract 1 from the power, I get 2. So I could put the 2 here, or, and this would be better, it's the power of 2 that goes here, so sine squared 2x. And simplifying, we have 6 cos 2x times sine squared 2x. In this example, what we have is cos 3x to the power of 4. So we can still use this formula. You can see the function inside the brackets is the cos 3x, like this, and the power is 4. So differentiating, use this convenient diagram, we know that if we differentiate cos, we get minus sine. So, starting with n, the power, so we start with a 4, times the derivative of the function in the brackets, the cos 3x, so we have to differentiate cos 3x. Differentiating cos gives minus sine, so we've got minus 3 sine 3x times the original function in brackets. So the original function is cos 3x to the power of n minus 1. So the original power was 4. If we subtract 1, we get 3. So we could write the power of 3 here, but it's better to write it like this. So we've got cos cubed 3x. And then simplifying, we have minus 12 sine 3x times cos cubed 3x. Differentiating the square root of 5x cubed minus 1. So rewriting this in index form gives us 5x cubed minus 1 to the power of half. So we're going to differentiate this. So using the result below, the function inside the brackets is 5x cubed minus 1, and the power is a half. So following the formula, n, which is a half, comes to the front, times the derivative of the function inside the brackets, so times the derivative of 5x cubed minus 1, which gives us 15x squared, times the original function inside the brackets, and the original function was 5x cubed minus 1 to the power of n minus 1. So we have to subtract 1 from the original power to give minus a half. Or we can write the derivative in third form.